Alright, now we're going to solve a system of equations using elimination. Again, this is a purely by hand method that's just to help you understand a bit of the algebra behind what the CAS is doing. So here we have two equations that are in standard form. So it's not the best to use substitution method here because we would have to rearrange the equations to do the substitution. So we can do what's called elimination. So the first thing we're going to do here again is label the equations. Really, this is just purely so it's easier to refer to. So I'm going to call equation A the first one and equation B the second one. Now how elimination works is what we want is to have the variables to have the same coefficient. So for example, I much prefer if this was 2x, so those two are the same, or if this was 3y, so those two have the same size coefficient. So what step 2 is, it's a little bit tedious. We multiply one or perhaps both equations to get one variable with the same coefficient in both equations. Now it doesn't matter which variable you pick, so I'll show both options here and you can proceed whichever way you choose. So the first option is to have both of the x's to have a 2 in front, which would mean I multiply equation B by 2. So this is a little bit algebraic, but option 1, my equation A stays the same, but I do 2 times the entirety of equation B. So this whole equation I multiply by 2, meaning I multiply each bit by 2. So what that's going to give me is 2x minus 2y minus 8. Okay, so that's if I made the x the same. Of course, I also have the option of making the y the same. So I could have done 3 times equation B. So instead of multiplying by 2, I would have done that whole thing times 3. So I end up with 3x minus 3y minus 12. I can proceed with either of these options. I will do option 1 just because it is a little bit trickier, but you can proceed with either option. But what's important is that you have the ability to essentially cancel one of the variables. Okay, so we're going to work with option 1, but you can choose option 2 as well. Okay, so first we made the coefficients the same. Now we're going to eliminate one of the variables, hence the name elimination. So here we're going to add or subtract the two equations to cancel one of the variables. So again, we're working with option A, or option 1, okay, where I've got 2x minus 2y equals minus 8. Now what I'd like is, again, to just have one variable. Right now I have x's and y's, I just want to have one variable. So what I can do is actually subtract the entirety of that second equation from the first. So if I do 2x minus 2x, well, that's just 0. So they eliminate, they cancel, hence the name elimination. Then for my y's, I do 3y minus negative 2y to give me 5y. So being really careful when you're doing that, and then finally subtracting these variable numbers, 12 minus negative 8, well, that's 20. Again, this you don't need to write down. You can definitely do that in your head, but it's 3 minus negative 2 gives me 5, 12 minus negative 8 gives me 20. So now, again, I just have one variable in one equation. That's a lot easier to work with. Now I just need to solve for y. Well, if 5y is equal to 20, I just need to divide both sides by 5 to give me that y is equal to 4. So now I have 1, I just need to figure out what x is. To do that, I'm going to substitute the value I know, so the y value, into equation B. I could substitute into equation A, but there's more happening there. It's just a little bit quicker to plug into equation B because there's less happening. So I know that x minus y is equal to negative 4, but I also know that y is equal to 4. So that means I can have x minus 4 is equal to negative 4. Take a moment to think about how you'd solve that. So how do I figure out what x is? Well, I need to get rid of this negative 4, so I add 4 to both sides to give me that x is equal to 0. So my x-coordinate is 0, my y-coordinate is 4. So my last step, stating my solution, Well, that's my x and my y coordinate, so it's 0, 4. Again, if you want to be really sure that this is indeed the correct answer, you could have used the CAS all along, or you can do a quick check. So I've got my two equations. Take a moment and double check that this solution is indeed correct by substituting into the two equations. Okay, so if I plug 0 in for x and 4 in for y, I get 2 times 0 plus 3 times 4 is equal to 12. So that's 0 plus 12 is 12. Whew, my two sides are equal, so that one's a check. 0 minus 4. Well, 0 minus 4, that's negative 4. So it does work in both equations, so that is indeed my solution. Again, this is just kind of, should be step 7, a good follow through to ensure that your solution is correct. So that's using the elimination method by canceling out one of the variables.